Hi and good afternoon, it's Gene from maverickstar Observatory. We're a little bit late on the data. That should have been delivered on the 17th of this month, but better late than never. Well, as you can see on the screen, we're looking at the latest position of the magnetic North Pole. The latitude of that is 83 degrees by 33 hours 17 minutes 66 seconds north, by the longitude 124 degrees by 48 hours 50 minutes 53 seconds east. So if you're following this on your Google Earth's map and you want to put the tracking location down, you've got the coordinates for it there. One thing I did notice today when we was putting the latest position of the magnetic North Pole, just before we move on, I'll just say that there has been an advancement of 4.3 miles from last month's current position. But one thing I did notice, let me just get rid of this off the screen so you can see what I'm talking about, is when we zoom out how close the 40-degree mark is to the northern central mid-Atlantic ridge. You'll see that it is almost virtually on it. And you know, I'd never paid any attention to it till recently, until we were starting to look into the South Atlantic anomaly, which obviously the South Atlantic ridge runs straight through that anomaly. I just thought it was strange that, you know, our 40-degree mark coincidentally or synchronistically falls right on the north mid-Atlantic ridge. So maybe you know, that could reinforce, you know, what we are thinking with regards to, you know, what will take place perhaps in 2 to 3 years when the magnetic pole arrives at that location. As you can see from today's pin that we've added, it is straight in the corridor and still tracking to that position in central Russia, just below the Arctic Circle. So let's move on and have a look at the TriMag data and the magnetosphere, because there's something equally interested in that. And I just wanted to talk about a little bit before we end this video about the Carrington Event and where it fell in the date scale going back 400 years of sun observations. Just, you know, I thought it'd be worth mentioning that, being we was talking about sunspots yesterday. So let's get on with it. Let's have a look at the TriMag data. So here we are on poleshiftnews.com looking at the TriMag data, which has been updated today. We can see that it is still hanging around the 13 degrees. It's actually at 1291 if I remember correctly, and any time now it is going to creep over the 13 degrees, and we're going to see it hitting 13 degrees more often. And that is also an indication of the magnetic North Pole still migrating in an easterly direction towards Russia. So that's, you know, as always, is, you know, we always get these bumps. There's been a little bit more activity, I think, just at a glance looking at what's been going on over the last month. Towards the end of the month, things have settled down a little bit, but it is a different story when we have a look at the magnetosphere data. Let's go over to that and have a look at that. So here we are at the Magnetosphere Data page, again on poleshiftnews.com. Before we go any further, just want to say a big thanks to those people that have been supporting the observatory over the last few days. And there's a link down there if you want to help support what we do. You can go over to the website, you can see there's a donate button there as well. And obviously it's a public funded observatory and therefore requires, unfortunately, public funding. We try and keep corporate funding off the website because simply we just don't want these corporations telling us what we can publish and what we can't. So I think the only way to keep it fair, truthful and honest is keep the corporations out of this. And sometimes, trust me guys, it is tempted. So just bear that in mind. Okay, the magnetosphere data. What is so interesting about it is you might see that at a couple of points this month it has hit the 198 microtesla line, and I've got to say this, that it has only happened once, and it happened once about 2 years ago if you go back in the archive of the data. So it could be from my, you know, initial looking at these charts this morning, it could be that we are starting to see a slight discrepancy in the strength of the magnetosphere, and therefore a gradual but slow weakening. And that is exactly what we would expect to see getting closer to the magnetic pole reversal. Now, when I say, guys, that this is on the doorstep, this really is on the doorstep. For the last 100 years, the magnetic North Pole has been migrating from Canada all the way over the northern hemisphere of our planet, and is currently just north of the UK or Greenland, to the right a little bit easterly, to the east a little, and is still covering on average around 4 miles every month, and getting closer to that 40-degree mark. But if you go back into the archive nearly 2 years, back to 2018, you will see that the only time that the microteslas hit the 198 scale on the bar left hand column was back then, and it has, if you look at these charts, gradually been dropping down to that level, and I think we're going to continuously see it drop off over the next few years and gradually weaken out. So I think that was interesting enough to mention to you, and you're more than welcome to go over onto the website and take a look at the archive of data and come to your own conclusions. But I'm pretty sure you'll agree with me, over the last few months there has been a slight decay in the magnetosphere strength. One other thing I did notice is that the measurements over the daily periods of 15-minute intervals, they seem to be getting more scattered. The fluctuation over the day is becoming more sporadic. I'm just wondering if that is another component of the weakening of the magnetosphere, and that's why we're seeing these scattered sine waves go closer and closer. It's almost like the frequency is getting higher and higher, so to speak. So the only other thing I wanted to mention, being we've got one sunspot on the disk, is the Carrington Event. I'm sure most of you are aware of the Carrington Event. Let's just pull up some information on it for you. So I just briefly wanted to talk about the Carrington Event, which was an event that took place in 1859. It was the largest geomagnetic storm ever recorded, and Carrington himself was the one that drew the right hand diagram of the sunspots on the sun, where the coronal mass ejection was emitted from. You may know about the Carrington Event, you may have read about it, but we had a similar event in 2012, as you can read here. And if the Earth had been on its orbit around the Sun just 9 days earlier, it would have struck the Earth, causing absolute chaos. As you can see, one of the things that really is affected by any coronal mass ejection or geomagnetic storm is the electrical grid. And of course, we've talked about this before, if the grid ever goes down, that means that fuel stations cease to pump the fuel. That means that the logistics of a country or many countries grind to a halt. Transformers explode because of the surge in the power lines, and it's not something that any government around the world has ever prepared for, yet these events have happened before, and history such as this event, the Carrington Event, shows us that it is possible. What I wanted to do is just show you 1859 on the 400-year sunspot scale, so you can get an idea of where the level of sunspots was at around that time. When I was looking at this yesterday, I couldn't see any reason for a Carrington Event to come out of the date of 1859, which what I mean by that is there wasn't anything significant at that time, like the Maunder minimum or the Dalton minimum, and as the sun then began to get back into the throw of producing sunspots, that could be the catalyst that triggered a massive CME. I had no indication or saw any evidence of that. It just seemed like a rare event, and if that's the case, and according to solar physicists today, they believe that we are overdue such an event, and maybe the 2012 was just pot luck and we managed to avoid that big CME or geomagnetic storm hitting the Earth, but that doesn't mean in the near future we will. Every bit of our technology is vulnerable to these geomagnetic storms, and more so is the satellites and infrastructure that we have in low orbit and high orbit. You know, they're at risk, and we are heavily reliant on satellites today for GPS, global communications, bank transfers, you name it. You know, we are so dependent on the grid and the electrical infrastructure that it leaves us so vulnerable. You would think that, as opposed to also building, you know, nuclear submarines and, you know, aircraft carriers that on the top of the agenda to, you know, safeguard continuity of governments around countries and stop these things, you know, taking place and then the country collapsing as a result of the infrastructure breaking down, you would think that we would stockpile transformers so that we could quickly repair any damage that was caused by coronal mass ejection. But that isn't the case, and you have to wonder why that isn't the case. Why are we so vulnerable in this day and age where we have the technological advancement and the knowledge to know that these things can occur? It is a failure by global governments and major organisations such as the European Space Agency and NASA. You know, a failure in them notifying the appropriate departments of governments that these things actually exist and pose real risks for us. But like I said, it will come a day when we will get hit by a coronal mass ejection, and to me there doesn't seem to be anything that gears up to give us an indication of by what the magnetic source is doing around these sunspots and the umbras of sunspots. But you know, I mean, we are less likely at this point in time, I would say, to have such a coronal mass ejection. I mean, if you look at the solar magnetic storms at the moment, they're almost bottom lining. The KP index rarely goes up, despite, you know, moderate little C-class and M-class flares that we might get occasionally. We certainly aren't seeing what we saw within the last decade, and that was those X-class flares. So I thought it would be worth, you know, just talking about this. Because we are in a grand solar minimum, and you know, the chances of a coronal mass ejection might be low, but still we don't know many of the mechanisms of our star in the centre of our solar system and how it works and what triggers these things. But we have some ideas. We know that when we start to see the magnetic anomalies build up in these umbras of the sunspots, then we can calculate what is likely to happen at that point. But you know, it took just 17 hours for the solar flare in 1859 to reach Earth, and therefore there is little preparation time because of that. And there was a unique situation that happened just before this large X-class, super X-class flare launched off the sun's surface, and that was there was a small CME in front of it which cleared most of the debris out of the way, and that is why it only took 17 hours to arrive at the Earth's surface. So we really do have very little warning time. You know, there's only a certain amount you can do in 17 hours or less, or in 24 hours for that matter. I think what would need to be done is, if it was detected and it was in line with striking the Earth, I think the best thing that people could do is put their electrical equipment, obviously switch off from the grid, unplug it, and then, you know, protect the electrical equipment from the geomagnetic storm as it arrives to the surface of the Earth by means of, you know, protective materials, boxes and tins and things like that, as we know is a good isolation from it. So let's just have a quick look before we end the video of where this occurred then on the 400 sunspot observations. So as you can see, the sunspot that is there on the disk today, you can see that the geomagnetic field is quiet and there are normal amounts of solar X-rays. So even though there is a sunspot, things are pretty calm. The KP index, it maxes out at just 2, so nothing to worry about there. If we go down to the chart I'm looking at here, 400 years of sunspot observations, and we put in around about the time where the Carrington Event happened, which was 1859, so near enough 1816, you can see that we're not by a Dalton minimum. That was 50 years before that, was nearly 60 years before that, and we're nowhere near the Maunder minimum for that matter. So it's very really, I could understand if we'd just come out of the Dalton minimum and at the peak of the Dalton, we're at the maximum there of the sunspot numbers just after the dip in the Dalton minimum. If we had the Carrington event there and perhaps another Carrington event around 1780, there would be an indication of perhaps a cause of these large coronal mass ejections, but there's just not. And again, we're at modern maximum times now. I know it only goes up to 2000, but it was in 2012 where we had that lucky escape from that coronal mass ejection, which could have delivered widespread chaos and pandemonium, wiping out grids all around the world. You can see that the sunspot numbers were at the maximum point of the time from 1950 to 2000, but had already started to drop off. So there is no real indication as to what causes these massive X flares that come off the sun. They do seem pretty unpredictable, other than the study of the umbra and the magnetics which take place in those during large sunspots that we observe, and that could only be the only indication that we would get of perhaps a large X-class flare. I don't know if you remember when we was in the main part of the activity, I think it was 2015, I did accurately predict the following day that there would be an X-class flare. I think it was mainly due to luck, to be fair, and that was only because we'd had a few already. So I do think it is luck when we do have these large events come off the sun, and for that reason they are pretty much unpredictable. So I thought I'd leave it there with you guys. There's a link down there if you want to help support what we do at the observatory, and big thanks for those people that have done already. Remember, we are at some strange times right now with obviously the pandemic that's going on, and therefore it would be great if we could see a little bit more support than what we have done over the recent months. And remember, we have lost around £700 worth of support that we usually get during the month. So if we can make some recoveries from that, that'd be absolutely amazing. And the only other thing to say is I will be producing a video later on with a bit of a rant in it regarding the stupidity that is taking place in the UK at the moment with regards to this pandemic. If you're interested in that, that'll be on there a bit later on. But other than that, you have an amazing day, and I'll say what I usually do. Take it easy. Bye for now.